There are a couple things about this one that you might find a little bit awkward. The first is that we're rationalizing a numerator, which you've like never done before. You've always rationalized a denominator. And the second thing is that we're going to use a conjugate to do that. And we haven't really used that word, I don't think, at all this year, but you did use them in trig last year and definitely as a freshman. Keep in mind a conjugate is just this idea of like the same terms, except it's like one term is added, the other one is subtracted. And we use these kinds of things to get rid of radicals, to get rid of i's, but really just to get rid of square roots and i's, which are also square roots of -1. If the radical is something different, you can't just use the opposite thing like this. There's a whole other thing involved. And if you want to know more about that, look into the binomial theorem. But I'll tell you what to use in the homework and stuff for this assignment. But I'm going to use the conjugate to get rid of this numerator. It does look a lot more complicated than what I wrote over here, but the concept is the same. The conjugate's going to be the exact same terms. So root x minus 5, root x, and then instead of a minus, I'm going to put a plus. And I'm going to do that exact same thing to the top and to the bottom, because I've got to be fair. And the whole point of a conjugate is it exploits this notion that you guys know from Algebra 2 of like, if I have two things that are pretty much the same idea, an A and an A, and a B and a B, and I multiply them together, but one's plus and one's minus, this multiplies out and becomes A squared minus B squared. Usually when you multiply two binomials together, there's a middle term, unless they have the pattern where these are identical, and one's plus and one's minus. When that happens, the middle term cancels and you get A squared minus B squared. So I'm not even going to really think a lot about what's happening here. I've set this up to exploit this pattern. I know it's going to become this thing squared minus this thing squared. It's always that way. It's always this thing squared minus this thing squared when we're dealing with square roots. Again, with this cube roots, different story. So x minus 5 square rooted squared becomes just x minus 5 minus this thing squared just becomes x, and that denominator is y times root, whatever the heck is left down there. I'm not too worried about it. I'm just kind of copying it down without thinking about it. So this entire product turned into this thing. This entire product, I'm not too worried about it. I'm just going to leave it in that form. No reason to go further than that. There really isn't. And I'll just combine like terms on the top. This x and this x knock each other out. And we end up with the final answer of -5 over y times this gross bit of business. That's going to make you feel oogie. You're not going to like it, but that is what we're shooting for. When you see it in the homework, it'll be in the context of trying to find the limit as h approaches 0. And when you get to the point where you have a simplified expression like I have there, you'll be able to plug in 0 for h. The h's aren't going to cancel off like they were on the previous assignment, but you'll have an expression where when you plug 0 in for h, you don't end up with 0 over 0. You end up with an actual expression that you can say, oh, this is the derivative. So that's kind of the point here. Just do your best to stay calm while you do it. You're definitely smart enough to take care of it. And if you have questions, set up an appointment with me or email me, and we'll definitely talk it out. Good luck.